Back everyone to Virtualizen Unplugged, where we explore the tools, trends, and real-world strategies that help businesses thrive in the digital world. I'm Mai, and I'm here with my co-host Danny, and today we're excited to talk about one of the most essential yet often misunderstood topics, wireless networks.
That's right. Whether you're in education, healthcare, or running a bustling office, wireless is the backbone of daily operation. And when it's not planned well, everything from collaboration to customer experience can suffer.
That's right, and to help us unpack this topic, we're joined by our in-house expert, Jonathan Garcia. Jonathan brings years of hands-on experience designing, optimizing wireless networks for organizations of all sizes. So do me a favor in welcoming Jonathan.
Welcome, Jonathan. We're really happy to have you with us.
Yeah, thank you, Danny and I appreciate that, and thank you everyone for tuning in. Today we're going to cover everything wireless. So from assessments to unique approaches and optimizations that we have. So I'm excited to get into it.
Amazing. So let's get to it. Jonathan, what are some signals that a business needs a wireless assessment before installing their latest investment?
Yeah, Danny, there's actually two different questions there. The first question is being able to identify the warning signs showing you that you need an upgrade. And then what do you need to know before you actually do those upgrades? So let's start with number one. The signals or warning signs can come from a multitude of different directions. It could be from employees or clients complaining about being dropped. It could be more users accessing the network with more devices, employees coming back to the office, you're growing and expanding and hiring more, or you might just have more foot traffic for consumer-facing businesses. Or it could be new hardware implementation. You're buying new scanners for your warehouse, say, or you have new devices that are Wi-Fi 6E or Wi-Fi 7 compatible. These are just a few of the possible signals or warning signs that you need to be on the lookout for to be able to show you that you need an upgrade or an expansion. Now, let's get to the second question. The most important thing you need to have in order to be able to know what you need to know before making that upgrade is information. So the more you have and the more accurate you have, the better decision you're going to be able to make. And from our position and our opinion, the best way to get the most information is through a wireless assessment, which I'm really excited to be able to dive into as we continue.
Definitely, Jonathan. Like you said, it's essential to evaluate how a wireless network is performing before making any big investments, because even the most expensive service can fall short without expert planning. So when we go onto a site, what is the first thing that we're trying to evaluate, Jonathan?
Yeah, our first step is to understand the client and understand where they are at. What is your current situation from a wireless perspective? Is it a greenfield environment? Is it an aging WLAN that you have? Are you expanding? Are you getting complaints? We do not have a one-size-fits-all solution because every client is different. Every situation is different. So the first step must be understanding the specific needs that you, the client, have.
I love that. And I want to highlight that part. Everything that we do at Virtualizen is customer oriented. Hey, Jonathan. So when a company thinks they've upgraded to the latest wireless gear, what are some invisible variables they are likely overlooking?
Hey, Danny, that's an important question and one that comes often when organizations invest in new wireless infrastructure, but they don't see the performance gains that they expected. So some common issues that are overlooked are invisible variables that can undermine the effectiveness of your latest wireless gear. One of the things is a lack of proper Wi-Fi site survey solution. Then what this does is identifies interference zones and dead spots. And if you don't do that, what happens is your new APs may still suffer from the interference caused by metal structures, machinery, or neighboring networks that your old system did as well. Another overlooked issue is compatibility issues with legacy devices, or roaming behavior, or on bad steering problems. Not all devices are going to be able to support the latest Wi-Fi standards, like Wi-Fi 6E or even Wi-Fi 7. And another additional overlooked issue that you can experience is insufficient PoE budget. So basically the power that you're having to send to those APs. Also outdated switches and single uplink paths that throttle performances. APs may not support, the AP might actually support the multi-gig speeds, but the switching infrastructure or the cabling doesn't. So that has to be taken into consideration when you're trying to make that upgrade.
Right, Jonathan. And we often see this scene play out. A school or a large company is excited about their big wireless refresh. The team unclips the old access point, snap it into the new one, and they plug it into the same Ethernet drop, and the job is done, right? Or at least that's what they think. But then comes a moment of truth. Is it going to give them the coverage that they need and that they already had previously?
That's a very common situation because far too many users assume that if my coverage was good with the old APs, then it should be good with the new. And unfortunately, that just isn't always the truth. With the introduction of Wi-Fi 6E and Wi-Fi 7, APs are now able to operate within a larger and broader range of channels, changing the output of the new APs. If this is not taken into consideration, then you will run into a myriad of problems leading to more costs and changes that you're going to have to do down the line, unfortunately.
Right, right. Jonathan, are you able to visually walk us through what a bad wireless install feels like from the user's perspective, even when the equipment is brand new?
Absolutely. I think the best way to do that is to be able to take a look at these two different maps that we have here. You'll see a before and an after. So the before map is going to be able to show you what happens when you don't consider all these changes that we mentioned before. If you're just going to be able to plug and play, replace the APs that you have now, you're going to run into the same problems that you possibly had with the old APs. So if you look at the map here, there are several gray spots. That just means that there's no coverage there. You're going to run into drops. You're going to run your if you have in this particular map, this is a warehouse. There could be scanners that end up dropping in those specific aisles. And so when that's not considered, you're going to run into these issues. So let's look at the after picture. We actually ended up going and redesigning this whole warehouse and placing the APs in places where we knew that we were going to get full coverage. And as you can see, you have coverage in all the different aisles where there's not going to be any drops, and no major issues. So it's important to be able to see these visuals that, yes, if you don't consider all those factors that we talked about before, you're going to possibly run into issues like this client did here. And we were fortunately able to help them out. But please make sure that you are taking into consideration all these possibilities so that you can get the best coverage that you can for your facility.
Perfect, Jonathan. Thank you very much. That was really helpful. Now, what role does physical space play in designing wireless networks? Are we still underestimating building materials when we look at Wi-Fi 7 or other new technologies?
Now, physical space plays a critical and often underestimated role in wireless network design, especially as we moved into a more advanced technologies like Wi-Fi 7 and the 6 gigahertz spectrum and multi-AP mesh networks. So for example, building materials, concrete, metal, glass, drywall, they all absorb or reflect RF signals differently, and those have to be taken into consideration. Wi-Fi 7 uses higher frequencies like 6 gigahertz, which are more susceptible to attenuation, especially through dense or metallic materials. Even small changes in the layout, like moving an AP across a hallway or into a basement, can drastically affect the coverage. Also, to be able to consider when you're talking about this in the physical space, open spaces like warehouses allow for better line of sight, but also introduce multipath reflections. The physical layout affects user clusters. So another situation is when you have different areas like break rooms or conference rooms, which can impact the AP balancing load. Wi-Fi 7 introduces what's called multi-link operation, or MLO. This is able to help you with that load balancing, but only if APs are placed and support seamless transitions, pointing us again to the importance of a proper Wi-Fi survey and a proper Wi-Fi design.
All right. So, and why does Wi-Fi 7 differ from older technology when clients try to maximize new speeds?
Yeah, great question. Wi-Fi 7 introduces several fundamental changes to wireless in general. Compared to older technologies like Wi-Fi 5 or Wi-Fi 6, it all comes down to more speed and more reliability, which we all want, right? For the more technical nerds, I have a few reasons here, kind of explaining a little bit more about what Wi-Fi 7 is able to do. So bear with me here. Might get a little bit technical, but it is important to be able to understand why Wi-Fi 7 is different. So one of the main things is that Wi-Fi 7 introduces wider channels, which essentially means you have more bandwidth, which equals faster speeds. So basically, it's up to 320 megahertz. Another thing that Wi-Fi 7 introduces, and I mentioned it before, was multi-link operation, MLO. What that is able to do is you're able to use multiple bands all at once. So you get to use 2.4, you get to use 5, and the new band, which is 6 gigahertz. You're able to use that all at once, and that equals, again, better speed and reliability. But this also requires precise AP placement, as we spoke about. Another advantage of Wi-Fi 7 is higher QAM. That means Wi-Fi 7 packs more data per signal. So just to give you an example, Wi-Fi 5 and Wi-Fi 6 would give you about 5 bits per symbol. And what Wi-Fi 7 is able to do is give you 12 bits per symbol. That's a 50% increase in data transformation. Again, faster and more reliability. The last thing that Wi-Fi 7 is able to do is something called smarter scheduling and lower latency. If one band is congested, like 5 gigahertz, it can shift traffic to the cleaner 6 gigahertz band instantly. And this reduces the latency and avoids bottlenecks. If part of a wider channel is experiencing interference, like from a microwave or a neighboring AP, Wi-Fi 7 can puncture. It's called puncture that section and still use the rest of that channel. Older Wi-Fi would drop that entire channel completely, causing delays and retries. See, Wi-Fi 7 is really just that next step up in the IT evolution, which will make your connectivity better and faster. So don't be left behind.
Absolutely, Jonathan. I completely agree with what you're saying. Don't get left behind. And for your projects, choose Virtualizen. Can you share with us, Jonathan, how Virtualizen approaches a wireless project differently from others and why our approach is unique?
Yeah, absolutely. Our market footprint gives us the agility and the exceptionally nimble and client focused. Unlike firms that push cookie cutter solutions, we tailor every wireless project to the specific needs and environments of our clients. We are able to offer many different survey types, and we're able to leverage many and diverse range of OEM solutions. We ensure flexibility at every stage. Every project includes a dedicated project manager, giving clients a single point of contact and peace of mind throughout the process. Our goal isn't just to deliver wireless. It's to deliver clarity, confidence, and control in a space that's usually very chaotic. We bring custom fit solutions that align with your operational realities, not just technical specs.
Thank you very much, Jonathan. That was extremely insightful. So it's clear that wireless networks are so much more than just the latest hardware. It's about design, testing, and anticipating how people and spaces interact.
Exactly, Danny. And for businesses planning on an upgrade or an expansion, a thoughtful wireless strategy can mean the difference between everyday frustrations and seamless operations.
Correct. So I want to say something to the audience. If today's discussion sparked questions for you and for your team, please visit us at virtualizen.com and also our official channel in LinkedIn, that is Virtualizen.
And Jonathan, thank you again for sharing your expertise. To our listeners, thanks for listening and joining us. Stay tuned for more conversations on the tech shaping tomorrow's world.
Thank you, everyone. I appreciate it.
Thank you, everyone.
See you.
Woo!
All right. How did it go?
Amazing, no?